So we just finished talking about molecular compounds. Now we can look at ionic compounds and ions and ionic compounds. So ionic compounds are made up of ions. So what's an ion? An ion is an atom that gained or lost an electron. So the number of electrons and protons are no longer the same. So it's not neutral. It has a charge. So cations are positive. That means that they lost an electron. So now you have more positive things than negative things. So overall you have a positive charge. So if you lose an electron, you become more positive. So metals like to do that. So metals are going to be on the left side of the periodic table, downstairs, right? So those are the guys downstairs. They're going to like to give up electrons. They're going to become more positive. Anions are negative. So the way you can remember cations versus anions, cations have the word cation has this T in it, right? So you have cations, which kind of looks like a positive sign. Cations. I had one student that said cats are positive. That's how she remembered it. Hey, whatever. Depends on if you like cats. Anions are negative, so they gained an electron. So it turns out the nonmetals on the right side of the periodic table are upstairs. The nonmetals like to gain electrons. So metals lose electrons, they become cations. Anions gain electrons, they become anions. What did I say? Nonmetals like to gain electrons and become anions. And how many electrons you're going to gain or lose really depends on how far away you are from being a noble gas. So let's go back. Oops. Let's go, actually, let me pull up this chart. So something like lithium. Lithium here has an atomic number of 3, which means if lithium is neutral, it has 3 protons and 3 electrons. Now, the closest noble gas over here is helium. Helium has 2 electrons and 2 protons. And so how can helium make itself look, or how does lithium make itself look like helium? Lithium's going to lose 1 electron. Now he has 3 protons and 2 electrons, so he's going to have a positive charge, but then he'll have the same electron configuration as helium. So then he'll have the same number of electrons as helium. So he'll have a noble gas configuration, which is pretty stable. So that's what's going to happen when it forms an ionic compound, or when it's going to form an ion. Lithium likes to give up 1 electron because he's only 1 electron away. Losing 1 electron will make him look like the noble gas in the row above. So it turns out everybody in this first column likes to give up 1 electron, and that makes them all have a positive charge. So we're talking about when you form an ionic compound. What kind of ion will you form? Depends on a lot of times it depends on what family you're in, what group you're in, what column you're in. So everybody in this first one, column 1, is going to have a +1 charge. Everybody here has a +1 charge. They give up 1 electron. They look like a noble gas. We'll learn more about this noble gas configuration later on in chapter 8 and chapter 7. These guys are going to give up 2. So group 1 has a +1 charge. Group 2 has a +2 charge. We're going to skip these transition metals for a minute and these heavier metals, because these can change. It turns out they can form more than one stable kind of ion. Aluminum likes to be +3. That's true. So we have +1, +2. Aluminum's +3. Those are the metals. Those are all the metals that have fixed charges. There's a few more in here. We'll talk about those when we need to. But working backwards now, noble gases, they're stable. They don't want to give up any electrons. They don't want to gain any electrons. They don't want to interact with anyone. Those are your noble gases. Everyone's trying to look like them. So anything right next to the halogens, and we have this H- here, you don't have to worry about this for the most part. It depends on what it's reacting with. But the halogens here, so you have fluorine, chlorine, bromine, they are 1 away. All you have to do is gain 1 electron, and they'll look like the noble gas over here. So they are happy stealing 1 electron. So they have a -1 charge. Oxygen's going to be -2. This whole family is -2, and then nitrogen's going to be -3. So you have +1, +2, aluminum's +3, and then working backwards, -1, -2, -3. You have to know that because in the next section, what we're going to do is we're going to write out the formula for ionic compounds. So we want to know if sodium and chlorine are going to get together. How many sodiums do I need for how many chlorines in order for this to be neutral? Well, it turns out sodium, you probably have heard of sodium chloride, right? Sodium has a +1 charge. Chlorine has a -1 charge, which means sodium likes to give up an electron. Chlorine likes to gain an electron. So that's going to be really stable because this guy gives up 1, he gains 1. Great, now now it's neutral. And that's an ionic compound. So just right here, like ionic compounds like sodium chloride, generally they're formed between metals and nonmetals because metals like to give up electrons and nonmetals like to gain electrons. So metals lose electrons to become cations, and nonmetals gain electrons to become anions. And then when they come together, once they transfer their electrons, then they're really really attracted to each other because they have opposite charges. So ionic compounds, right? Usually between a cation and an anion, a metal and a nonmetal. Remember how molecular compounds were just between nonmetals. So we have to be able to look at different compounds and say, is this ionic or is this molecular? Because we're going to name them differently. We're going to follow one set of rules when we have molecular compounds. We'll have another set of rules when we have ionic compounds. So in this exercise, we're just going to try to figure, is it molecular or is it ionic? So we'll do a couple and then you should pause it and try to fill out the rest. So N2O, what are you going to have to do? You're going to have to try to figure out, is this a metal or a non-metal? And right away, you may not be, you might not know them cold. You have to look at the periodic table and you see, okay, N and O, they're both upstairs. So these are non-metals. So if I have two non-metals, then that would make that molecular. So this is a molecular formula here. N2O, that's a molecular compound. Now Na2O, well, what's Na? That's sodium and oxygen. So you go back over to your periodic table. Sodium's over here. Here's sodium, and oxygen's there. So I have a metal and a nonmetal. So a metal plus a nonmetal gives me an ionic compound. So I'm going to name this guy a little bit different than I would this one. And then we'll go over naming in the next section. So try to pause the video, finish the rest of these, and see what you get. So calcium chloride, I'm going to assume that you paused already. Calcium is a metal, chlorine is a nonmetal. So calcium chloride here is going to be ionic because it's a metal and a nonmetal. Sulfur is a nonmetal. Fluorine is a nonmetal. So these are both nonmetals, so that's molecular. CBr4 carbon is molecular. Carbon is a non-metal. Bromine is a nonmetal. So two nonmetals, that makes that molecular. Iron's a metal. Sulfur's nonmetal, so that would be ionic. Phosphorus and oxygen are both nonmetals, so that's going to make it molecular. And lead is a metal, and fluorine is a nonmetal, so that's going to be ionic. So that's your first step. You just kind of have to, get used to looking at the periodic table, figure out, what is what, and there you go. And the next thing that you're really going to have to do is start memorizing these charges, just like we did over here. So now we're going to put them together. We're going to write some formulas for ionic. We're just going to focus on ionic compounds now. So how do we write the molecular formula for ionic compounds? Ionic compounds are going to be neutral. They're going to be made up of ions. But overall, you want them to have a neutral charge. So you want the number of positive ions that you have to equal the number of negative ions that you have. The overall positive charge has to equal the overall negative charge so that you get 0 total. So you have to be able to look at these, in the formula. So if I said, okay, a formula involving magnesium, then you go and you look on the periodic table. Don't even show you the charges yet. Here, you know that magnesium is in column 2. It's an alkaline earth metal, so because it's in a column 2, it's going to have a +2 charge when it forms an ionic compound. So everybody here is +1, everybody here is +2, aluminum's +3, and then working backwards, we have our nonmetals. Skip the noble gases, and then you have -1, -2, -3. So if you can count to 3, you can do this exercise. So +1, +2, aluminum's +3, -1, -2, -3. There's a few other metals in here that I'm going to make you memorize. Might as well show you now. Zinc and silver. So zinc is right here, zinc, and zinc's always +2. And silver is over here, and silver's always +1. So it goes 1, 2, 3 on a diagonal. Yeah, 1, 2, 3 on a diagonal. So you have +1, +2, and then 1, 2, 3, -1, -2, -3. All right, so we'll know all of those. Now,